Hello, my dear students. Linear functions. How can I identify that a function is linear? A function can be given as a graph, and it can also be given as an equation, and it can also be given as a table. So in this lesson or in this video, we are going to learn how to identify if the function is linear or not given graph or equation or a table. For a graph, a function is linear if the graph is a straight line. This is straightforward and it's very easy to identify if the function is linear or not from the graph. So if it is a straight line, then this is a linear function. It comes from the word linear, it comes from the word line. Number two, if you are given an equation, how can you identify if this is linear or not? Equations of linear functions can be given in standard form or can be written in standard form. So the standard form is ax plus by equals c, where a, b, and c are just constants and x and y are the only variables. If you notice here, the exponent of x and the exponent of y are both 1. So we have no power on the x and no power on the 1. This means that the power or the exponent is just 1. So when we have only two variables, x and y, and their exponents is just 1, which is not written, and we have constants, then this means that this is the standard form of linear equation. So if we can write or rewrite the equation in this form, this means that this is linear. If we cannot, then this is nonlinear function. Let us have an example here. Determine whether this function y equals, or this equation y equals 3x power 3 minus x power 3 plus 3x plus 6 is an equation for a linear or nonlinear function. To identify this, we are going first thing to simplify or combine the like terms. So to combine the like terms here, we have y equals, we have 3x cubed minus x cubed, both of them have the same power, so we can combine them together to be 2x cubed. And then plus 3x and plus 6 is the same, so we are going to write it like this because we cannot combine them. Now this is the simplest form of the equation. After that, we are going to rewrite it as standard form. If we can rewrite it as standard form, we know that the standard form is ax plus by equals c, where x and y have powers 1. Now look at this equation up here. We have x with a power 3. So because we have a power 3 on the x, this means that this is nonlinear function, and we are going to write nonlinear function. Now let us have an example for having a table of a function, and we want to know if this table of a function represents a linear function or nonlinear function. Okay, for a table, this is different now. We don't have a line graph and we do not have an equation, but we just have values in the table for x and y. Okay, to know this, to determine linearity from a table, we will find the slope between 2 points, like the first and second point, and another 2 points, like for example these 2 points. If slopes are the same for both pairs, then it is a line, and if slopes are different, then it is not a line. Okay, this is obvious because if we have a straight line like this, if this is a line, if we have 2 points and we take the slope between these 2 points, and then we have another 2 points on the same line and we take the slope between them, we know that the slope between each 2 points is equal to difference in y values over difference in x values, or y2 minus y1 over x2 minus x1, which is change in y over change in x. Okay, if we have the same line and we take these two pairs of points and we take the slopes between them, we are going to find that they have the same slope. So we have the same slope for the same line. So to identify that a function is linear or not from a table, we're going to take the slopes between two pairs of points. Let's have the slope between the first 2 points. So here's y2 minus y1, x2 minus x1. We have the y's here, which are y2 is 28 and y1 is 2, so we're going to subtract 28 minus 2 over x2, which is 0.5, and x1, which is 0. This will give me 26 over 0.5. Okay, 26 over 0.5, we can make it mentally because 0.5 is half, and dividing any number by half as if we are multiplying it by 2, so this will give me 52 for the slope. Okay, this is the slope for the first pair. Let us have a slope, the slope of another pair, any other pair. Okay, I will choose these 2 points. So we'll take y2, that is 52, minus y1, that is 58, over x2, that is 2.5, minus x1, that is 2. Now 52 minus 58 is negative 6 over 2.5 minus 2 is 0.5. As if now again, as if we are multiplying negative 6 by 2, which is negative 12. So the slope between the first 2 points is 52, and the slope between the second 2 points was negative 12. So this means that they are not equal. This means because the slope is different, so this means that it will be nonlinear function. I hope you understand, and to the next video. Bye bye.